Yeah, I believe all the attendees are here. So let's begin the session. First of all, guys, I'd like to thank you for joining us and taking out the time to be with us here today. We are going to be doing a Tekton 101 workshop, which would be hosted by Mohammed Hanzala. Before I pass the floor on to Hanzala, please quickly let me introduce myself and Stikator. Stikator is a community of battle-hardened ninjas who assist their customers to fully utilize Kubernetes in their environment. So how do we assist our customers? We help enable them in two ways. The first one is consultancy, where we basically help enterprises navigate the CNCF landscape by evaluating and integrating desired technologies tailored to each customer's particular environment and stack. So if I were to break that process down into 3 steps, so step 1 would be we evaluate your existing environment. Step 2 would be a team level discussion regarding what end results are we all trying to achieve. And the third one would be to propose a roadmap or an action plan to achieve the desired result. And the second one would be the managed services, also known as Decatur App Agility Platform. It is a community favorite. So basically, it's our fully opinionated managed DevSecOps platform on Kubernetes, on which we manage all day 1 and day 2 operations. So while you focus and while we are managing and operating your deployment, you focus on a more stabilized offering for a larger customer base and your entity's commercial goals. Now, we want to make this session more interactive before I pass the floor on to Hanzala. So I just want to quickly see if there is anyone who would like to introduce themselves, where they're working, and if they're using Tekton 101 at the moment, and in which capacity are you using it? So would anybody like to step up and introduce themselves?
Well, hello, hi. I'm Naeem from Pakistan. Actually, I'm a senior software engineer working in the capacity of a team of 10 people in the backend side. My specialties are in Ruby on Rails and JavaScript, and I have keen interest to learn new technologies and also the cloud native stuff. So I haven't used this Tekton, so I'm really excited to uh, join this workshop.
Perfect. That's a great introduction. And can we have another one for maybe an individual who has used Tekton or is currently using Tekton in their environment, if we have one?
Hi, I am Monidul. I am currently in Dhaka, Bangladesh. I am a lead DevOps engineer working in Grameen Telecom Trust. We are here using GitLab CI actually, GitOps. So I am really interested to see today's session.
Perfect. Thank you for that introduction. So I believe we do have a very diversified audience from different geographies and in different pipelines. So Hanzala, whenever you're ready, I'd like to pass the floor on to you.
I think Hanzala is muted.
Okay. Oh, sorry. I was speaking and.
No worries. All you.
Okay. Great. Can you hear me now?
Yeah, we can hear you now. How are you, Hanzala?
Okay. So yeah, as you can see in the screen, this guy with the glasses is me. I'm just a bit more older now. So this is me, Mohammed Hanzala. I work as a DevOps engineer at Stikator. I'm also a DevOps trainer, conducting different boot camps webinars and workshops like these. I've been doing this since last 3 years. I've conducted different workshop webinars, on-site trainings with the corporate sessions as well. So I've been doing this, and this has been my bread and butter. And then there's a lot of experience with Docker, Kubernetes, and OpenShift, and this is what I spend my day and night with. So Kubernetes is one thing that lives with me more than anyone in this planet. I'm not really proud of that. So yeah, so the agenda of this workshop is I'll just go through what is Tekton, why we should use Tekton, and all the theoretical things that why Tekton is a good choice. And then I'll go into the practical aspects of the Tekton list, like how you can implement that, what are different components of Tekton. You might have heard that Tekton consists of so many different tasks. So we will go into the depth of each task. We will see the examples of each we'll see the examples of each component. We have a Tekton task, Tekton pipeline. So we'll go to the pipelines and all the practical aspects as well. I'm going to run lab myself. You guys have been granted cluster permission as well. I'll be doing some examples in the middle of workshop, but you are welcome to do your, as you have granted permissions as well. We will also share the code base that we're going to use during this workshop. So we will share in the Slack, and we will also share in Zoom chat as well. So you can perform yourself as well. If you can't go with the pace of workshop, then it's not an issue, because you can always access it. You can always do the hands-on lab at the end as well. We're going to give you a time. We have a workshop ready. We will give you access for that you can run end-to-end some examples yourself. We're going to give you time, and I will be sitting here in case you need some guidance. So there's going to be hands-on lab as well. I'll be performing, as I said, some examples during the workshop. You are welcome to perform it along with me. If you cannot catch the pace, you can do that later as well. Yeah, so let me just go through the Stackator offering as well. So basically, we provide three kind of service: fixed price service, time and material, and Kubernetes support. And we have these blocks for each kind of users. Be you a Kubernetes a newbie or a powered user, or you have been using Kubernetes since long. We can assist you at any stage of your Kubernetes journey. If you're a container newbie or a container adapter, we can, if you want to have a quick jump start, like if you want to see if the container is right fit for your solution, if container solutions are best for your organization, you can always contact us. We will give you a detailed summary or detailed documents of if the container is good fit for you or not. If you're already using a container and you want to have a quick jump start on Kubernetes, so we can take your applications and deploy that to Kubernetes, and we can give you a jump start, and your team can carry from there. And if you're already using a Kubernetes since long, and you want to have us review your platform, or you want to see if you are using some best practices in terms of security, in terms of performance, you can always contact us, and our team will analyze your clusters, analyze your environment, and we will give you a detailed document of if you're doing it in the right way or not, and recommendation of how it can be optimized. Other than our fixed price offerings, we do have support for time and material as well. We also offer a consultancy service as well. We have tons of ninjas on Kubernetes. We have who has a lot of experience and certified by different organizations like Cloud Native Computing Foundation, Google, and so many certified individuals who can assist you, who can work as a consultant as well. And we also have as I said, we also have as a platform managed service that we call Stackator App Agility Platform, that we can run on any cloud, on any infrastructure. So these are the offerings that Stackator provides. You can always contact Usman or any sales guy.
Yeah, I would just like to make a quick comment on these. I will be sharing my email address, and gentlemen, I will be following up with you regarding any feedback of this particular bootcamp, and maybe what do you want to see the next time around when we host one. So if you have any questions, I will be sharing my email, and I will be reaching out to you. So please feel free to jump them and just ask questions if you have any. Cheers.
Good, great. Okay, so let's dive in. Let's jump into the event workshop. so let's start with a very basic example. A very basic question: what is Tekton, and what are we talking about? Some of you might have heard the Tekton and you just clicked let's explore what is Tekton, and some of you might already know Tekton but you want to know more about Tekton. So there are different kind of audience we have. So I'm just going to give a bit introduction of Tekton and why Tekton is a good choice. I'm assuming that everyone is already familiar with CI/CD, continuous integration and deployment, and they must have used different CI/CD tools like Jenkins, GitHub Actions, GitLab CI. Tekton is just another CI/CD tool in the community of CI/CD tool. In the community of CI/CD, how is it a good choice, and why we should use Tekton over the tools? Uh, so these are just it is a standalone project that provides an open source and native Kubernetes CI/CD solutions. Tekton is a CI/CD engine that runs on top of Kubernetes. I think that's one of the main unique thing of Tekton that others does not have. That Tekton works natively with Kubernetes. What natively means, we're gonna go through on that on next couple of slides. We will also perform some practicals as well, so you will know. So Tekton runs natively on top of Kubernetes. It means that you can utilize the infrastructure of Kubernetes for running your CI/CD engine, and that makes possible thanks to Tekton for letting us use Kubernetes for CI/CD. Because Kubernetes has always been used for the purpose of the deployments and all that stuff, but it has never been used as a platform for CI/CD tools. So Tekton let us use Kubernetes for the CI/CD purpose. So the main goal why we should use Tekton, other than it is a Kubernetes native, there are some advantages why we should use Tekton. So Tekton is highly customizable. Well, when I say customizable, it means that we can ship a piece of code. You can just consider like you make functions and you just export some functions, and anyone in the world can use these functions by providing their own parameters and getting their desired output. So Tekton is quite a range of tasks, you can cover a wide range of tasks with the Tekton. This is not something that you write multiple times and use multiple times. It is something that you write once and use multiple times. So Tekton has something called task, and we define Tekton task with some sort of parameters, and with those parameters it makes it highly customizable. It means that every pipeline, anybody in the world can use that task by providing their own parameters, by considering their own desired output. So Tekton is quite customizable. How you will see it, of course, in the later section. It is reusable. As I said, you write it once and you use it multiple times. It's just like a function in the programming language. You make it once and you call it different times with different parameters and you get different outputs. So it's just quite highly reusable. You don't have to write every time different code for the Tekton pipeline. You just use it once and you can use it in different ways with multiple pipelines, all that. Third thing is declarative. It means that whatever we do, whatever we create, it's all done via YAML files, via files. So it means that automation is quite possible when we have something declarative. It means that everything that is created for Tekton, everything that makes the ecosystem of Tekton is done is done with a declarative way. Like we define some sort of YAML files, and that makes the Tekton ecosystem. And since it is declarative, it means that if for any reason we lose the cluster, we lose anything, we can reproduce it very quickly, because these are just files that we have to create it again. It's not something in the memory, it's not something in the manual process that we create. Like it's not something manual. We click button 1 and then button 2 and then button 3. It's all YAML files, and we can easily reproduce it as well. And it is also a Kubernetes native. As I said, you can use your Kubernetes infrastructure for CI/CD engine purpose as well. And Tekton is also a cloud native CI/CD. So Tekton is also a cloud native continuous integration and deployment. What does it mean by cloud native CI/CD? So when we say CI/CD, it means that there are containers. It means that whatever runs there, whatever steps pipeline perform, it perform as a container. So if you don't know the advantage of containers, I will just point out a little bit of advantages of containers. In containers, you don't have to set up a platform upfront. It means that you don't have to provision a cluster and then you have to install some application, some libraries, some third-party tools for your pipeline to run smoothly. You can just do it with a Docker image. You can just build the image once, and then you can use it so many times. So you don't have to manage servers and install third-party tools and all the libraries and all that stuff. It is done automatically. Because we just have a Docker file, and when we use containers, it is quite portable. As you know, that this is one of the big advantages of container, that it is quite portable. It means that if you have to ship the platform, if you have to ship that to the environment, you can do it very easily. If you are running right now in G Cloud and you want to run it in a different environment, you can just ship the platform, ship the environment by just giving away the image reference. So it is quite and it also solves the problem of noisy neighbors. As I said, if something goes wrong in one step of the pipeline, it does not affect the others, because it is running as a separate container. Container isolate different process in different containers, so it has a different file system, it has different everything. So it just give us it just isolates tasks from each other, and it means that if something goes wrong, it's not going to affect other applications and anything in the cluster. Second thing is, it is serverless. It means that everything runs as a server. Everything runs as a container. So the container only runs whenever the pipeline is executed. So when the pipeline is not running, we are not consuming the resources. So containers only prop up and go down when on demand. It does not run all the time and it consumes your resources. So it means that when the pipeline is not running, you can always utilize your infrastructure for different purpose. You can always use it for a different purpose as well. Only the Tekton engine runs all the time, but the pipeline steps, the actual steps that takes a lot of time and memory and resources, it is just serverless. So it runs serverless. It just consumes resources whenever it is running, and it is designed to keep DevOps principles in mind. So as you know, that we have a different services, different teams, and different teams write their own pipelines, and they want to manage access on that someone want that they want to manage access. Someone don't want to have access of their pipeline to the other teams. So it is designed with that principle that you can always control the access of those pipelines and all the components of Tekton. So that's what make cloud native continuous integration and deployment. All right, and then just to go through what are the Tekton benefits. So Tekton is Kubernetes native. As I said, Kubernetes has itself a lot of advantages. Like for suppose that you don't have to worry about scheduling of the containers in the Kubernetes ecosystem. You just define how much memory, how much limits I want, and Kubernetes schedule everything itself. So you don't have to do it yourself. So this is one of the main advantages of Kubernetes. Kubernetes is a container orchestration, or quite popular container orchestrator. It has a lot of advantages. So when we run Tekton on top of Kubernetes, it means that we get all those benefits of Kubernetes along with the pipeline. And as I said, it runs pipeline in container. It runs pipeline container. Container itself has so many advantages that I just went through in the last slide. And then it is also a serverless. It means that no resources consumed when you are not running anything. The good thing is you can build images, because normally in the pipeline you use different image building tools, because you need to build Docker image for your application. So you can use it with Kubernetes. You can use Kubernetes tools like Canico, like Builda, Podman. So you can use those tools, and the components are quite decoupled. As I said, you can use different components with different combinations. Like you can use the same task again and again with different pipelines with different parameters. So these are quite decoupled. It means that you don't have to rewrite each and everything again and again. So these are quite decoupled. So these are the advantages that Tekton brings to the table. And then we have some contributors of Tekton. It is backed by Continuous Delivery Foundation. We have a contributions from Red Hat, IBM, Google, CloudBees. Just for your information, Tekton pipelines are a part of OpenShift now. So OpenShift also manages Tekton pipelines as well. We can also install natively on OpenShift as well. So that covers our theory step. What Tekton brings to the table. Do you guys have any questions about anything? I would like this workshop to be be engaging so that we can do two-way communication. It is not like a webinar that only speaker is going to speak and other is going to just listen. You can always interrupt me in the middle and ask questions. And I would like to have this more engaging as much as possible. So anyone, if you have any questions, you are free to ask regarding anything. Okay, I will take the silence as no, and I will move forward.
Yeah, so
okay.
far so good, Hanzala. Thank you. Let's go forward.
Yeah, great. Okay. So we have seen what Tekton brings to the table. Now we need to see how Tekton works, because eventually you analyze that, okay, Tekton is a good choice for you, but now the question is how to implement that. And as I said, there are so many components of Tekton, so it is just good to go into each and every two main components of Tekton and deep dive into it, how we can implement Tekton. And how we can implement pipelines in Tekton. So so the basic steps, basic thing that is common in all pipeline is a step. A step is the smallest unit of execution. So whatever we run in the pipeline is a step, and we define each step in each container. So Kubernetes step is basically a container in which we run different command, different process in the container. So as I said, Tekton runs as a container, everything runs as a container. So we have to define that which image is going to be used for the step, for the task. So we define everything, and we define what command do we need to run in a container. So it could be a git image, and we can clone some we can clone our applications into the step, into the task, and we can write all that into the step. So step is the smallest unit of execution. Whenever it runs, step becomes a container, and it performs whatever we define in the spec YAML spec file. And as I said, it's all YAML file, it's all declarative. So we define everything with YAML files. It means that whenever we lose anything, we don't have to remember, okay, what did I do last time, which button did I click. I just have to, I know the file, and I will just apply kubectl apply -f or kubectl create command, and then it's going to be created. So step is the smallest unit of execution, but it is a part of task. So there's a task, and task consists of multiple or single step, and we define task in a step. So if I just if anyone have a prior knowledge of Kubernetes, I would just compare. I would just say that task is basically a pod, and step is basically a one container of it. So when you define, so in task you define series of steps, and each step become a container of that pod, and we run everything uh, as a pod. So okay. Okay, so we define everything as, okay, once there right. Okay, so so smallest unit that we can define is step, and we define sequence of a step in the task. So when we define the pipeline, we define series of task, and task in terms execute series of steps. So we have if you guys are familiar, like when we define any object in Kubernetes, we define its API version, we define kind, we define metadata, and we define spec. So this is called basically a custom resource object, custom resource definition. We have Tekton comes with set of CRDs, custom resource definitions, in which we define things in a Kubernetes native way. It means that if you look at this, we are defining like we create a pod, like we create a deployment. So when we create different tasks, when we create different tasks, it just translate into Kubernetes native objects. So as I said, it is a Kubernetes native CI/CD pipelines. It means that it gives us a Kubernetes native way of configuring pipelines. So we had a smallest unit of execution that we called step. Then we had a task in which we defined series of step. But when we define a task, it does not mean the task will be executed. As I said, I just compare it with the function in the programming language. When we define a function, defining a function is a one thing, and calling a function is a one thing. So right now, when we create a task, we don't run it. We just define the function. We just define the task. in order to run that function, in order to run the task, we create something that is called task run. So task run is something that execute the task. So if we have to run one task in the pipeline, we just create task run of it, and the task is executed against that. So if you see, task run is nothing, it's just a normal Kubernetes file. And we define the task reference in it, like we define which task do we need to run. So as it is quite visible by screen, that what it does, it is just on the top part of it is just a normal Kubernetes file, like API version, kind, metadata, and spec. And then in the spec, we define which task do I need to run. So as I can see that we have a task hello world that we created in the last slide, and it just executes that. So let me just show you the example of it. Can you guys see my Visual Studio?
Yeah, I can see that.
Okay, awesome. So I've defined one task with the name test task. It is taking one parameter. As I said, the task is quite customizable. So we define some parameters, and we can just use it as we want, and we can use it as many ways as was possible. So for the sake of example, I've defined a simple task, and then in this tab, it just say echo hello world. So it just say hello and the whatever name we pass into the parameter. So we have a task called test task, and I also have a task run that we call task run hello world, and we are just reference the task that is created in the last one, and we are providing a parameter. Okay, so the name is me. I'm just greeting myself. So okay, let's create it. I will go into the task example. I will first create task. By the way, I'm using OC. You can use kubectl as well. Since I've already granted OpenShift access. I think you guys all are granted access. So yeah, okay. So if I have to see where we have a task created, I will just go to the OpenShift console. You all are granted that access. Can you guys confirm me that you can access OpenShift console as well?
Yeah, we can, but there is no task.
Yeah, there's no task. You will need to create yourself. So the code I'm going to be using in this workshop is already pushed over here in the workshop -Tekton. So I think you can find that link in the Slack channel as well, or I can paste that link in chat of Zoom. If I can find.
The link is already there in the chat. You can find it in the chat as well and in the Slack channel.
Awesome. So the code is all there. You will be granted your own user access. Mine is user 40. You will have your own user, and you can create yourself as well. If you can't go with the pace of this, because since I'm presenting, so I'll just perform my task. If you can't go with the pace, then you can always perform at the end. We will give you a time. We have designed customized workshop for you guys that you can perform yourself. So you will be granted access to that as well. I think the link has already been given in the Slack channel as well. So I can see that the task has been created, but there is no execution of it. It is just a task right now. There is no execution of it right now. So it's not running at the moment. In order to execute it, or you can say it, in order to invoke a function, we need to create task run. And in task run, we provide some parameters as well. So this is the task run that I'm going to create. The task run I can see in the console over here, the task run. So I'll just apply task run. And I'll see it has been created. Okay, so you can see that it has printed my name over here. As you can see in the task, we have echo hello and then the parameter name, and in the parameter name I have provided my name as well. So this is the task, and as I said, each step is a container. So let's see the pod. So this is the pod that was created against the task run, and then and if I want to see the container, it says step -echo -hello world. So this is the name of my step. eco-hello dashboard. So we can see that every step is a container. If I had multiple, then I would have multiple containers over there. There's an init container that just initialize something, but the real tasks are displayed over there in the containers. So we can see that the containers, so each task is a container, and in order to run a task, we have task run. So step is a smallest unit of execution. Step is defined in the task, and in order to execute a task, we define task run. Guys, any questions still here? Do you understand what is the task, what is step, and how do we instantiate a task?
I have one question. Will this meeting be sent to us in recording form so that we can discuss again?
I think Anam can comment on that.
No, the stuff is confidential, so no, we won't be sending you the recording.
Okay, because right now it's getting like over my head because I'm looking into the Redshift hat console. So I think I was creating from the pipelines model. Task isn't created in my, so that's why I was asking, because it's getting a bit
Yeah, because
fast.
the lab access, as I said, lab time will be given to you at the end of this as well. We have designed customized workshops for you that you will be performing. So as I said, if you can't go with the pace for the practical, like you can't perform along with me, you will always be given time at the end to perform and ask questions if you are stuck somewhere.
Okay, fine, thanks.
Also, if you have any question after the session ends, you can always ask us in the Slack channel, and we'll try our best to get back to you.
Right, just a
Thank you.
question on the lab availability. How long we would have access to that after the session is over?
You will have for a day.
Right, okay, thank you.
By 26 January, you will have this access. If you face some issue, you can always tell us in the Slack channel that you are given access to.
Okay, I created the task run and it is failing. Status is failed, and the message I see is like failure on task run hello world, check error for details, and log is like error while listing tasks for task run. Test.
Did you create a task as well first before creating a task run?
Yeah.
All right. Sorry, what is the error?
Okay, it says like test dot no task dot tekton dot dev test task dot found, and actually maybe I gave the bad name. I can double check actually.
Yeah, maybe you can check the name, because you can always check the task over here by going into the tasks.
Okay.
And then you can see that
It's a bad name.
you can see that. Yeah, maybe yes. So you can check the task over here as well. The task is always displayed, because by the error you are saying, it shows that the task does not exist, which you are trying to call in the task run.
Okay. I like the name was wrong. I changed the name. So thank you.
Yes. Okay. Okay, good. It's running now. Awesome. So yeah, now you guys all are hacker man. When your code says hello world, it's just a best feeling. And this is the only code that works on the
Hanzala, we cannot hear you properly.
first time.
We missed around 15 seconds of your time last you were speaking.
Yeah, right around and after the Hackerman pun.
and sometimes
I'm just in contact with Hanzala. We are sorting out the issue. Just give a second.
Yeah, guys, just give us a minute, please.
Sure, okay.
hello, can you guys hear me?
Yeah, we can right now,
Okay, sorry, I think there was some trouble in my internet.
but we cannot see your screen.
Yeah,
So
I
yeah.
will share the screen again. Can you guys see my screen?
Yes, perfect.
Okay, all right. Yeah. All right. So we have run our first Tekton pipeline. So congratulations to all of you who were able to make it. And task, we run series of different tasks on the pipeline. So right now the single task is called task and single task execution is called task run. But when we have to define series of tasks, number of tasks that we have to run sequentially or parallel in the same workflow, we call it a pipeline. And pipeline is nothing, it just consists of basic unit of Tekton that is called task and steps. So it just runs a series of steps in the pipeline. So as you can see, that pipeline is a collection of tasks that you define and arrange in a specific order of execution as part of your continuous integration flow. Guys, this Azan going on with my internet connections, and I don't know that can you guys hear me now?
Yeah.
Yeah.
Yeah. Okay. I'm just taking a 2 minutes of break because Azan is going in my internet.
Okay, sure. That's all right.
Yeah, guys, we'll just be pausing for 2 minutes. There's some background noise going on, so we'll resume the session in 2 minutes for everybody.
Hello, can you guys hear me?
Yeah, we can.
Right, we
Okay.
can hear you. Just before we continue, could you show the slide where the list of all the components of Tekton was listed? Task run, pipeline, and what others were there? Just wondering. Okay,
Yeah.
just three. Okay, thank you.
So these are just related to task. We have more concept as well. Right. Okay. So just let me know when I've stopped talking because there's something going on with my internet connections, and I don't know that if I'm speaking and you guys are listening or not. So can you just give me a final call that you guys can hear me?
Yeah, you're good to go for now. I'll let you
Okay.
know.
Okay, great. Okay, so I was just saying, I don't know if you guys heard or not, but when we say pipeline, we don't just
We lost you again, Hanzala. I think you just should rejoin again, if that helps.
Uh, Hello, can you guys hear me now? I'm just back with the new connections. I hope it worked fine.
Yeah, we can.
Okay. All right. Let me know when I stop again. I'm just using different connection now, so hopefully it works this time. But if you guys lose me anytime, you can just tell me. Right. Okay. So, so I'll just repeat it again that I just told twice before. So pipeline is a collection of tasks that we define in specific order. So when we define pipeline, we define multiple steps, multiple tasks that we need to run. So pipeline is nothing just a series of tasks that we run in the pipeline. As you can see on the right hand side, when we are defining pipeline, we are defining series of steps that we need to run. So as you can see that this pipeline consists of two tasks. One is scaffold unit test, another one is build scaffold web. So scaffold unit test is referencing the task that is called unit test, and build scaffold web is referencing the task build push. And as you can see, we have defined run after. So it means that it will make sure that the first task is executed before the second task start running. So to define a series of steps, we define run after in order to say that, okay, which task need to run after which task. So normally in pipeline, we first clone the code. So the first step of every pipeline is check out code. And second step is build image. And build image cannot be done unless the code is checked out. So it means that build image has to run after checkout image task has been done. So we define those series with the task with the run after. And again, pipeline is just a pipeline. When we define pipeline, when we create pipeline, it does not run. It's just a pipeline, just like, as I said, a function which is not being called. So just like a task run, there is something called pipeline run, and pipeline run does nothing. It just run the pipeline, as you can see on the screen on the right hand side, uh, the API version kind metadata is just a Kubernetes YAML format that we defined. And in the spec, as you can see, that we are referencing the pipeline that is called demo pipeline, and we're also defining the service account name. We can also omit that field as well. So in the pipeline run, we are specifying which pipeline do I need to run. So it is a pipeline that runs series of steps in defined order based on inputs and outputs. And the execution of pipeline is called pipeline run. We can define the sequence of execution with the thing called from and run after. And then after time, and we can also specify timeout, retries, and spec templates. I will show you the example of pipeline as well. And as I said, this has all been pushed to the GitHub repository that we have shared in the Slack channel. Can you guys confirm me again that you guys can see my Visual Studio code, my Visual Studio screen?
Yeah, look at it fine.
Okay, good, awesome. So as you can see that I have a pipeline that takes parameters, because pipeline can take parameters as well. So right now, as you can see that we are taking parameter call name. and we are running two tasks. One is called first task and another one is called second task. In the second task, we are passing the parameter to the task. So the task got the parameter by the pipeline, and we define those parameters in the pipeline run. So pipeline run pass those parameters to the task in the standard workflow. So if I show you just task, so task one is nothing, just it says echo first step, and task two is nothing, it just take the parameter and says hello, just like this, just like the old task that we run earlier. And in order to run pipeline run, I just created something called pipeline run, where I'm generating a name. And then in pipeline run, we are specifying parameters and its value. Right now it's Hanzala. Maybe I will call it workshop. And then we are specifying the pipeline that we have created earlier. So I'll just go ahead and I'll just create task and pipeline first. Task.yaml. And then I'll create pipeline.yaml as well. I want to see that pipeline on my console as well. So if I go to pipeline, I'll see the pipeline workshop dash pipeline has been created. It has two steps, first task, second task. And I can also see its YAML over here as well. So as you can see, it's not been instantiated. It's not running right now. In order to run it, I need to type OC apply -f pipeline dash run. I need to apply pipeline run, and I'll see it over here. Oh, I need to create command. I'll see the pipeline is running right now, and as I can see that second step was stopped before. It was waiting for the first step to be completed, and now since the first step is completed, now the second task is running. Since we have defined run after in the pipeline definition, that it's supposed to run after the first task execution is completed. And if we just see the logs of it, we see it's the first task and second task. And again, it's just the tasks that are running. So in order to run task, we need to create task run as well. But this time task run has been created by pipeline run itself. So we do not create task run ourselves. The task run has been created by pipeline run itself. So against each task, we can see that the pipeline has created associated task run, and task run has created pod, as you can see over here. So the standard workflow is like we define pipeline. In the pipeline, we define task, and then we create a pipeline run. And in the pipeline run, we define task run. And there's a pipeline controller that is already installed in the cluster. It just translates those things into Kubernetes native objects like pods. As we have seen that against each task, the pod has been created. So it is the responsibility of pipeline controller that just translates the object of pipeline and pipeline run into associated pod and container spec, because we don't define pod ourselves. It is the responsibility of pipeline controller, and it is looking for the pipeline run object and the pipeline objects, and it just create associated pipeline pods and where we run a pipeline. And there's also a thing called pipeline resources. Now it has been deprecated in the new versions. It used to be like the input and output sources like Git and all that. Now we clone it as a code now. Earlier we used to define pipeline resources like Git, and it used to clone itself. But due to different limitations, pipeline resource has been deprecated, and we clone the repository as a normal step, as a normal task in the pipeline. So that's how we define pipelines, pipeline run, and then associated pods. And we have seen the examples as well, that how pipeline runs. We create pipeline run, and then pipeline, and then the task. So the smallest unit was step. Step comes as a part of task. In order to run task, we create task run, and then we have a pipeline in which we define series of steps. And in order to run pipeline, we create pipeline run, and against each pipeline, the task run has been created, which creates associated pod. And in that pod, we see that our steps run. So we can see that eventually there are pods that runs, but how these pod runs, it is managed by Tekton controller. Any questions till this slide, guys? Let me know if I'm going too fast or if I'm speaking too fast. You can stop me, by the way, because I speak too fast. So
Yeah,
I
I
just
think
want.
so far so good, Hansel. I just wanted to mention something. I think in your good code for pipeline tasks, YAML is a bit fishy over there. You may want to check it later on. That have
Is
some
it a pipeline?
issues. The third one, tasks.yaml.
Yeah.
No, go into the pipeline
Okay.
example. Yeah, and the third file, tasks.yaml. I think you have some issues with the pasting the code there.
I can just verify by just doing that directly as well.
Yeah, I think that's the part you selected should be there. The part in the top should be removed. Okay, just a FYI on that. You can continue. Thank you.
But I will check as well. But I can also take a quick look as well. So if I just paste it over here and if I apply it, I see it got applied. So, but I will double check because I cannot find any issue right now. But I will check. It is a local copy of my working local copy. It is a remote copy of my local working. But anyways, I'll just double check it again. So yeah, so this is how we run pipelines. Now the third part that is very important is you might have seen that right now we have created manually pipeline run, but in normal scenarios we don't create it manually. Normally pipeline runs when there is some commit done against the git repository, or when there is some pull request open in the application repository. So it is always created on demand. Pipeline always runs on demand. It is not run manually. We are not supposed to create pipeline run manually all the time whenever we have a new commit or whenever we need to invoke pipeline. What a normal standard workflow is like: someone commits a code, and then when it is pushed, pipeline automatically runs. So it means that pipeline run has to be automatically created. So as you guys already know, there is something called webhook in the Git. What is webhook? Webhook is basically it notifies a webhook URL when there is some sort of events. So webhook consists of three things. That one is event, other one is payload, and the third one is configured URL. Event is when some particular event occurs in the Git. For suppose pull request is created, or it's merged, or it's synced, or whenever there's any push to the repository, or anything, it occurs. It gets generated on the event. And it also has the payload. I will also show you the webhook as well. So it also has a payload. In payload we define in payload is automatically generated by Git, in which we have a different sort of information like Git branch, commit ID, author, commit time, and all that thing that we need to have. So it is all defined in the payload. It is a JSON object. And then we also have a webhook configured URL. So one thing is webhook generator that is done by Git. And we also need to have a listener that should listen for those events and then should also extract the payload. So we have something called webhook configured URL, and that URL in our case is from EventListener. So EventListener is something that basically listen for the events in the Git. We add a webhook in the Git, and we give the URL of the EventListener, and then we add that. And whenever there's a new event, new commit that we specify in the webhook, it is passed to the EventListener, and EventListener then starts the pipeline. And how it starts the pipeline? It starts with the trigger templates and trigger binding that I'm going to cover in next 2 slides. So as you can see, EventListener is a Kubernetes custom resource that allows user a declarative way to process incoming HTTP-based events with JSON payload. It works with the triggers that is trigger template and trigger binding. So EventListener is an entity that listens for the event, and it does nothing. It just passes those requests to the triggers. And what those triggers are, we will cover in the later. So you can say that whenever there's a new commit, when a new commit is done, the push event is generated, and it is passed to the event listener webhook URL, and event listeners process it and it passes it to the triggers. So there are two triggers, trigger template and trigger binding. Trigger consists of two things, that is called trigger template and trigger binding. So trigger template is a resource that specifies a blueprint for a resource such as task run or pipeline run that you want to instantiate or execute when your event listener detects an event. So trigger template is something, it is a resource that we want to create whenever event listener detects an event. So for suppose event listener detects some event and we need to run pipeline on case of that. So we define that, okay, in the resource templates, as you can see, we are creating a pipeline run in the resource template. So whenever event listener passes the request to the triggers will create pipeline runs, will create whatever it is in the resource templates. In our case, because we need to create pipeline run on demand, so it's going to run on that. It is going to create pipeline run with the spec that we specify. So as you can see that this pipeline run exactly similar to what we have defined, what we have created manually ourselves. It is just defining some parameters and it is also referencing the pipeline run. But as you can see, there's one difference between what I had in the pipeline run before, that I was just hard coding the value in the pipeline run. But here we are just taking the values from the trigger template. So trigger template also have its own parameters, and these parameters are being passed to the pipeline. So we are not specifying the value for it. And why we are not specifying, that will have answer in trigger binding. So trigger template basically just passes those, it just accepts some parameter. Trigger template also accept the parameters like pipeline and task, and it passes to the pipeline, actually pipeline run, and pipeline run then pass to the task, and task to the task run to the task. So trigger template is just a resource that we want to create whenever event listener detects an event. And we also have a trigger binding. Trigger binding is a resource that specifies the field in the event payload from which you want to extract data and pass it to the trigger templates. So as I said, trigger templates exposes some parameters, but we need to get those. If we need to get those parameters from the webhook payload, like for suppose that if I have to clone the Git repository, then I need instead of hard coding the Git URL in the task or pipeline, I can just take it from the payload, from wherever it is generated. So for suppose if I have 10 repositories, I can use the same task and same pipeline, and I can take the parameters from the payload. So I can take the parameter of the Git revision or Git URL from the payload and pass it to my task, and the task is going to clone that URL or that repository. So in order to take parameters, to take parameter values from the payload, from the event payload, we just create trigger binding, and we accept values from here. As you can see that we are taking values right now in case from body.headcommit.id, body.repository.url, or header.content type. These are different fields that are exposed by a payload. So we just get values from there. So standard, what it looks like, there's an event listener pods listen for those event. It takes values from trigger binding and then passes into a trigger template, and whatever the source trigger template creates, in case pipeline runs, it just runs the pipeline. So this is what it looks like. Event is generated in case of push, pull request, whatever it is. Event is generated, then from event payload, the data is extracted in the trigger binding. Trigger binding pass that data to trigger template, and trigger template creates that resource. Just to simplify that, I'll show you because it will be much easier for you to understand. So these are some sort of permissions that event listener needs, because in order it has to create some pipeline runs, so it needs to have those permissions. The service account need to have those permissions. So these are the permissions that event listener need to have. And then there's an event listener, as you can see over here. In the event listener, we are specifying service account name, that has the permission to create pipeline runs. And then we have specified trigger, and in the trigger we define the condition in which we have to run the resource. So for suppose that if I have 10 events generated and I need to run 10 different pipelines on 10 different events, I can also define interceptors as well, that in which condition do I need to run my pipeline, do I need to trigger template. So here we have defined that if the X GitHub event is pull request and body.action is opened or synchronized, then in that case refer this trigger template. So if you're curious about which values is it taking, I'll show you the payload as well. So if I go into the settings, you need to have admin permission for that, for any repository to work. And then I'll just type the password. Oops. All right. And if I just look at the past deliveries, one that was successful, I can see it has some headers. Like, so we are looking for the header that is called X GitHub event equals to pull request. So right now there's a header called X GitHub event that is pull request. So it means that this condition is satisfied, and then it looks for the other condition, like if the body.action is opened or synchronized. So we will look for the body and we look for the action that is opened. So it means that this condition has been satisfied. Once this condition, this is called interceptor. And once this condition has been satisfied, it will pass the request to trigger templates and trigger binding. So let's look at the trigger templates as well. So in trigger templates, we are specifying nothing, just a pipeline run. And we are using the same pipeline that we ran earlier. But in this, we are just passing the branch name as a name. So whatever branch we're gonna open pull request on, it's just gonna say hello branch 1 or branch 2 or whatever. And it's just gonna execute. It is just the same pipeline run as we had in the last one. As you can see over here, it is exactly the same. Just the parameter is different, and we are creating it with trigger templates, and we are passing this value that is coming from here to the pipeline run. And if you're curious from where it is getting this parameter value, the answer is trigger binding. So as you can see in trigger binding, I just need to take the reference of the branch. So I will look for the event that is called body.pullRequest.head.reference. So if I have to see that over here, body.pullRequest dot it was head reference. Yeah, it's over here. So in order to extract data from the payload, I have a trigger binding where I can reference from which path I need to take my parameters, and these parameters are passed to the trigger template, and in trigger templates further pass it to the pipeline runs. So as we can see in the pipeline runs, we are just running it. We are just calling a pipeline. So let me just create event listener. Event listener RBAC. And we can create event listener as well, along with trigger templates and trigger binding. So it's just going to create trigger template. Oh, there are multiple. And then trigger. Okay. I can see it from here. I have an event listener pod that is running right now. This is the event listener pod that's going to receive the request, and it is exposed on the route. So whenever someone sends a request on that route, it is received by this event listener pod. Right now, it does not have the payload, so it is just throwing a log error that it does not have the JSON input as a body. So whenever we are sending a request to this URL, this route, it is being intercepted by event listener pod. So we're gonna add this URL to our webhook. I've already configured it, but I will just do it again for you guys to understand things. So I'll just delete it over here. I will add a webhook. I'll have the payload over here, and then I will change to application/JSON, and I will select events. So I want to send it in case of push and pull request. Push is already, this is the push, and this is the pull request. So it means that this webhook will only generate events in case of push or pull request, nothing else. And in webhook listener, we will define that in which events we have to take actions. So here we defined in which case it's going to be triggered, and in the event listener we defined in which events we're gonna be taking actions. So as you can see that it has been configured. I'll go ahead and I'll just create a PR over here, any PR, because we have configured it on the pull request only. As you can see in the event listener, that it will just only listen on case of pull request is open or synchronized. So I'll open as pull request. I'll just make a change in README. I will also open pipeline as well, so that you can see that it creates a pipeline run when we make a PR. So let's make a PR. Let's just make a change over here, and I'll just make a new PR. I'll say branch of branch 40. Not merge. So as soon as I will make a PR, I'll see the pipeline run has been created over here. And this pipeline run will as normal as it used to run. But in the second step, we will see that it's going to extract the branch name. And from where did the branch name come from? Branch name came from the payload, as we can see over here. We can also look at the payload as well in the webhook. And if we need to see the recent deliveries, as you can see in the trigger binding, we are taking pull request.head.reference. So I'll just see head.reference is branch-40, and this value is being passed to trigger binding. And trigger binding further passes through the trigger template. This is being passed over here, and trigger template further passes it to the pipeline run, and pipeline run further passes it to the pipeline, as you can see over here in the parameters. And the pipeline
Hanzala, sorry, I'm cutting you. There's a question in the chat. Can you please check it?
Sure. Let me where did you configure Tekton? What do you mean by Tekton? You mean Tekton controller? Tekton installer? Is that what you mean? If you mean this, so I can show you that we have a pipeline controller that is running over here in the OpenShift pipelines namespace. You guys may not have access to that because I have a cluster admin permissions.
I think what he might be asking is like when you have a OpenShift cluster, where you get the Tekton. Is it like how you install it? Is it somehow
we install it with operators? Okay, I got the question. Thank you. Does it have instance for Tekton? Yeah, so we have the controllers that is running all the time in the cluster, and we install it with operator hub. In OpenShift we have but it can be installed in many different ways. You can install directly, you can install with YAML files, you can install it as an operator as well. We install it as an operator. As you can see, we have installed operator that is running OpenShift pipeline operator. So OpenShift has a concept that is called operator hub. In operator hub, we install operator. So as soon as we install that operator, it just installs some CRDs and these controllers that's going to listen for the pipeline and pipeline runs and all that, and converts that to the Tekton objects, as we have seen in this screen, that there's a Tekton controller that is watching for the pipeline and object, and it just converts that into the pod and all that. So this is how we installed. Does that answer your question, Raj? Okay, great, awesome. Thank you for asking.
Just a question on the webhook URL. Where did you get that?
Yeah, so yeah, that's a good question actually. So in the EventListener, we have created something called route, and it is similar to ingress. So EventListener X creates a Kubernetes service. If I want to see it over here, I can see that in the services, and I will go into my Zofati. And this is created by, when we create EventListener object, it was created automatically by EventListener. This is something what EventListener does itself. And in order to expose outside, just like if you have used Kubernetes ingress, it is just exactly similar to ingress, that it exposed this service outside. So we generate it with this route. This is also pushed in the Git as well. So this actually, when we send a when we create a route, it automatically gives us a URL. And when we click on this URL, it just sends a request to that service that is for EventListener. And this request is received by EventListener pod, and then EventListener pod takes some action on the basis of that. Does that answer your question?
Okay, so EventListener is the one that's gonna create a route, and okay, that's the URL and the location. Okay.
Yeah. So route is basically created externally. Route is created by ourselves, as you can see over here. Service is something that is created in order to expose a service outside. Do you know about Kubernetes service?
Yeah.
Yeah. So basically, EventListener has created Kubernetes service, and in order to expose this Kubernetes service outside the cluster externally, we created a route. Route is exactly similar to what Kubernetes ingress is. It just exposes it to some host.
Right. Yeah. Yeah. Understood. Thank you.
Yeah. Yeah. So the request is received by the event listener pod. So that's how basically it runs normally, right? When we are in the real environments, we make a commit to the repository, and then we make a push over there, and then the pipeline starts working, and it starts the normal flow as we run. Anybody have any other question before we just go to the end of this session and we start hands-on lab?
Yeah, I think there are two
Yeah,
questions in
Hanzala,
the
I
chat.
believe,
Thank you.
yeah.
Was the default webhook was the default webhook and CICD for GitHub? I think I don't understand what is mean by default webhook, but webhook, that is webhook is a part of all the Git source code. Like for GitHub GitLab, it is generated by it is a feature of the source code repositories like GitHub GitLab, and we define the webhook listener that is called event listener in the webhook URL, and webhook sends those requests on the basis of particular events to the event listener, and event listener takes some actions like creating a pipeline in our case. Does that answer your question, or if you can elaborate further, I can answer.
Hanzala, my question was in regards like right now we are using Tekton. So
Yeah.
if we are not using any CI/CD tool, so what's the default one? Like if I try to push code on the GitHub, so what would be the webhook URL and what the process you just defined, like code pipeline and event listener? So what's the default one if we are not using Tekton there?
Yeah, so when we don't have anything, we don't have anything configured. Like for suppose that if you create a new repository and you make some push, there is no webhook configured. I just created those two myself, so nothing is there by default. We just add it automatically. If we have to trigger pipeline, then we define webhooks, and then if we don't have to, then we don't define any webhooks. If I just delete both of the things, then nothing is going to be triggered on the
So
pipeline.
how GitHub runs pipelines?
You mean GitHub Actions?
Yeah.
Okay, so GitHub Actions has native way of getting the events, and it runs pipeline. So in the GitHub events, we define which events do we need to run pipeline. So GitHub Actions is something very native to GitHub, so they have their internal implementation. But even if you work with Jenkins and all the and or with any external CI/CD system, you configure the webhooks. And in case of GitHub Actions, it is just done something internally.
Okay, so in terms of Jenkins or other CI/CD, the same process is being implied, right? The
Yeah,
webhook
but
and the same
yeah,
process you just defined.
exactly.
But there might be
But they
some
don't have
different.
a trigger. Yeah, exactly. There is no trigger template, trigger binding. Jenkins has their own concept. But yeah, we do
Okay,
have the
but the
webhook over
concept is
there as
same,
well.
right?
Yeah, exactly. So just
Okay.
just in case if it is a black box for you as a developer, that when you make a push and how does the pipeline runs, so the magic is the webhook and event listener.
Okay.
This is
Okay,
the
okay,
magic.
got it. Okay,
Yeah.
thanks.
Good, great.
We have one more question from Christian and Raj as well.
Right. So does Tekton allow for rollback in case for any issue during deployment? Okay. So Tekton does not, as I said, Tekton, if Tekton deploys something, it just runs kubectl apply command. It just runs some kubectl command. So you can also roll back. You can roll back manually, but it is something that you have to write yourself the logic. Tekton just provides you engine and it provides you some native steps, but rollback implementation and all that you have to implement yourself. And it is not something that is a native feature of Tekton. You can of course, because steps and tasks are defined by you, and it has to be defined in the task. All right. And the second question is pipeline running by parts of Tekton that you install with operator? No. So pipeline generates different parts. So there are parts for the controller. If I go to this screen, so these are controller are itself some parts that are controller. But when the pipeline runs, it creates its own pods. Or it is not pipeline controllers. It just creates and deletes pod on demand whenever there's a new pipeline run and all that. So they are two different set of pods. Pipeline controller has different pod, and pipeline pods are different. Raj, does that answer your question? Yeah. Okay, great, awesome. Anybody have the other question? So just to overview, we have an event listener that listens for the events, and then we have a trigger template where we defined which resource do we need to run. In our case it is pipeline run, and then we have a trigger binding that extracts info of the payload to be passed to trigger templates, and interceptors where we define the conditions when we need to pass requests to trigger templates or trigger binding. Trigger templates, trigger binding, and interceptors makes something called triggers. Triggers is also a separate resource, but we are specifying directly in the event listener. But trigger templates, trigger binding, interceptors are called triggers. So just to give you an overview, so just to sum up what I've said, we have a task. We have something called step that is missing because step is not object. Is a part of task. So task is the step is the smallest unit of execution that we define in the task. In order to run a task, we define task run. And when we have to run multiple steps, multiple tasks in the pipeline, we define pipeline where we define multiple tasks. And in order to run pipeline, we define pipeline run. You can take task, you can consider task and pipeline as a function, and task run and pipeline run as a function instantiation when we call a function. And we have an event listener, trigger template, and trigger bindings in order to generate pipeline run dynamically. So we don't have to create manually ourselves. We always create on demand on the Git events. There's also something called Tekton CLI. I've been using OC, but in order to simplify that, you will also use in your hands-on pipeline as well. TKN, there's a CLI which can be used to list pipeline resource. For the sake of simplicity, I use OpenShift console for looking at pipeline resource and the logs and all that. But you can also use TKN. Tekton, as I said, Tekton is highly customizable. It means that sometimes you don't have to write code yourself. You can always use the catalog that is defined by Tekton. Like Tekton ships some of the tasks that you can use yourself by providing the parameters, just like a git clone task. There are some tasks that comes by default. If I show you, if I go to cluster task and clusters are basically are same. The difference is basically cluster task is available for all namespaces, while the task is only available for a particular namespace. It means that it is just restricted to a particular group of people, while the cluster task can be used anywhere in the cluster. So task I've defined in user 40 cannot be accessed by you, but these cluster tasks can all be accessed by you as well. So they ship some of the tasks that can be useful in different scenarios. Like for suppose we have a builder task that is used for building images and push the image. We just provide some parameters. So these come as a part of OpenShift or Tekton catalog. So we have to define these parameters. We don't have to write code. So in order to call checkout step or build step, we don't have to write code ourselves. We can just use this task and we can provide parameters whatever we need to, and we can have things done. So it is quite highly customizable, quite reusable as well. So this is what Tekton comes with. All right, any questions at the end?
Just a quick one on event listeners. You have a couple of YAML files there. Is there any specific sequence that you want to run those YAML files and configurations for event listener?
Sorry, can you repeat? We have so many files here. I understand.
Right, you have 4 YAML files, right? So is there a specific particular sequence that you want to run those files?
Yeah. So basically, the RBAC needs to run first, because you may not be able to run this RBAC because it has a cluster role and it can only be created by cluster admin. So you may not be able to create that cluster role. But yeah, the role has to be created first before the event listener. You can like it can be created after that as well, and event listener going to pick up, but it's going to fail for once and twice. It's going to be restarted again. But yeah, like first you create RBAC and then you create the rest of the files. But even if you create all at once, it's going to be created anyways. It's going to work anyways.
Got it. Thank you.
All right. Any other questions, guys? Okay, so we will jump into the hands-on lab. For the hands-on lab, Anam, can you confirm that the link has been sent to them?
Yeah, so I have sent the link in the Slack channel, so you guys can get it from here, or you can get it from the chat section in the Zoom meeting as well.
Awesome. Thank you, Anam. So you can just start the workshop. Now I'm gonna mute my mic, and you can perform the lab yourself because it has everything defined. And if you have any question, you can always unmute yourself and ask questions. Um, just you have been
We lost you, Hanzala. Can you check your connection again? Okay, everyone. So I have resend the workshop link as well. You can find it in the chat.
Perfect. So while we wait on Hanzala, I believe we can just get ready for the workshop.
hello.
Yeah, we can hear you now.
Okay, good. Okay, so I was just saying that you guys have lab access for 1 day. You guys can always access it, and it has everything written everywhere that you may need to run in order to complete this task. So you have a web console as well access, and then there are some tasks that are defined over here, and there's a description that is well defined. So if you face issues somewhere, I'm just going to mute myself now, and you're going to perform yourself. If you don't want to continue right now, you still have access for 1 day more. And then if you face an issue, you are already added in our Slack channel, you can always ask us. We will try our best to assist you as much as we can during the time you have access. And please leave us feedback as well that I'm going to share. Um, and yeah, can you guys confirm me that you guys can access these labs?
Yes, Hanzala, I can access the lab. Just wondering, that is not timed, right? So you can do any time within this time specified, like until tomorrow.
Yeah.
Okay.
Yeah. But like right now, if you want to perform right now, if you have any questions, I can answer you live. But if you face something later, I'll try my best to assist you in the Slack channel.
Sure, that would be great. I just have to drop. Thank you guys. It was great presentation and learning Tekton, and thanks Anam, Usman, and Hanzala for organization.
Thank you. Thank you
We
for joining.
appreciate the kind words. Thank you for
Thank
joining us.
you.
Thank you for
So
joining.
I've just we have some exciting stuff coming on in the next month. So I have just dropped a link in the Slack channel for our LinkedIn page. You can go there and follow us and get updated. Thank you everyone for joining in.
Yeah, and I'm here muted myself. And what's the login credentials? I think login credentials has been sent to you via email.
Yeah, I've just sent you. I have sent you the email name. Can you please check there?
Yeah. If you feel something, please let us know. I'm here for next 20 minutes, and then we will log off. And then you can always ask us in the Slack later.
And guys, I think I do have a hard stop, so I'll be parting ways. Thank you for joining us, and I will be following up with you guys regarding a feedback survey and maybe what do you want to maybe see a boot camp or a webinar regarding anything that we can do for you next month. So we'll quickly do a review for that. So please expect an email or a call from me. It's been a pleasure, guys. Have a good one.
Thank you, Usman. It's nice to have you.
Thank you, Usman.
Thank you. So Raj, there's a question from Raj. Does it have feature like GitLab provides for the mostly DevSecOps domains, feature like image scanning, task, compliance, and many more? Yeah. So again, as I said, there are things that that you write in your program. Tekton does not have native support for all that. I think no CI/CD engine has. we just install some tools externally and we try to integrate those steps as we try to integrate those things like image scanning, dash, sonar cube, and all that as a part of our pipeline. So even it is GitLab, you are always writing some tasks, you are always writing logic yourself to integrate those things yourself. So you can like as you do in the GitLab, you can always do in Tekton or in any CI/CD engine as well. So but it depends on your logic. How do you write that logic? How do you write that step? You need to write that step task yourself for the image scanning and all that. So yeah, it is not just like GitLab. It is like something that you integrate in your pipelines, and you can do that here in Tekton as well. Yeah, can you just tell me that you guys are doing the lab, and just you guys can just confirm me that we are doing a lab. So yeah, just good for just for FYI. And since you are also have the cluster access, so you can also perform the labs that I have performed during the workshop. You have access to the GitHub, so you can clone that and you can start doing yourself as well. Just for the information.
So I think everybody will perform the lab later on. So Hanzala, I think we can end the session, right?
Yeah, yeah, we can end the session, I think. And if you guys have any questions, you can always, you are part of the Slack community channel. You can always ask us, and we will try our best to answer you over there, considering our day-to-day responsibilities as well.
Yeah. So thank you everyone for joining us today, and thank you very much that you all have joined us in from different time zones. And if you have any question, as Hanzala said, you can always ask us in the Slack channel. Have a good day. Thank you.